One type of energy can turn into another type. Energy is a quantity that an object possesses because it has some property or motion. Energy is like money of physics. Systems with a lot of energy can do a lot of things. People with a lot of money can do a lot of things. But systems with little energy cannot do many things. Energy is scalar. That means energy does not have a direction. However, energy amounts can be negative because it's possible for some systems to go into an energy debt. Just as a person can go into debt regarding money, reducing their freedom to do things even more. So, energy is scalar. There is no direction. Sometimes energy can be negative. And that's only with certain systems. For the most part, like kinetic energy, is not ever going to be negative. If an object is moving, the object has kinetic energy. The amount of kinetic energy is calculated according to the equation K equals 1/2 mv squared. And now you see how kinetic energy can never be negative. You can't have a negative mass. If you have a negative velocity, that's squared, so that's got to be positive. So kinetic energy has to be positive. And there it is. This means that kinetic energy can only be positive. There is no kinetic energy debt. On the AP Physics 1 equation sheet, which is kind of outdated at this time because we got electricity and sound and stuff, but it's still going to look like this. K equals 1/2 mv squared. The location may change by the time you're watching this video, because I'll probably not keep recording them every year. If an object is located above ground level, the object has gravitational potential energy. The amount of gravitational potential energy is calculated according to the equation U sub g equals mgy. Remember what g was. M is the mass, g is the gravitational field the object is in, 9.8 newtons per kilogram or 10 newtons per kilogram on Earth. Y is how far off the ground the object is located. Mass and gravity have to be positive, but it's possible to be in a hole, which would be a negative height. Right? So if you're below ground, then you have a negative height. This means that gravitational potential energy can be negative. So it is possible to be in gravitational potential energy debt. And here we are on the equation sheet. Again, location may change. Delta Ug equals mg delta y, where delta y is your height. The amount that your gravitational potential energy changes is directly related to the amount your height changes, because that's what it is. Thermal object. If an object has temperature that is above absolute zero, then the object has thermal energy. All objects have thermal energy. Every object in the entire universe have an object above 0 Kelvin. Temperature comes from the fact that atoms and molecules wiggle around in different motion. This means that particles have kinetic energy as they wiggle. The total of all those kinetic energies is the object's thermal energy. In physics, we don't care if the particles are atoms or if the particles are molecules, so we just call them particles. The higher the temperature, the more the particles wiggle, and the more thermal energy the object has. The more particles an object has, the more particles wiggle and contribute to the thermal energy. So the thermal energy of an object has been determined by the object's temperature and how many molecules it has. Thermal energy is sometimes incorrectly called heat. Heat is something that you add to a system. Chemical energy. Any chemical bond carries energy. The total energy possessed by all the chemical bonds in an energy is its chemical energy. We're not going to talk too much about this, but it's good to know. You can look for more of this in chemistry class. The bonds in gasoline have more energy than the bonds in water and carbon dioxide. Therefore, when gasoline is burned and becomes H2O and CO2, there is less chemical energy after the reaction. So the remaining energy has to go somewhere. Thermal energy, or giving a car kinetic energy. Before we get into this, let me show you something. So chemical energy in America, we use a measure of it known as the calorie for foods. Around the world, that's not necessarily the case. For example, this food blog from Australia. We've got some fries here for you. Let me move this out of the way. And you see the comparison of the energy that is stored within these fries measured in K capital J. Well, that K is kilo, means times 10 to the third, and then joules. Our calories here in America are measured in kilocalories. We just don't put the K in front. We just use a capital C instead of a lowercase c. But around the world, you may come across kilojoules, and that's just a measure of the amount of energy within that. Obviously, the lower joules that you eat, the healthier you could consider it, right? So you see the small fry here is only 1070 compared to 1900 for the large. That's it.